Well, hello there, and welcome back to the GameDev Tavern. This is a nice and peaceful and secluded little corner of the internet where we just chill as we create fun little games together. My name is Nicholas, and this is episode 11 of the tutorial series where we create a 2D pixel art soccer game in Godot. Greetings, fellow travelers. So, in the last episode, we worked on our header ability. It's a little bit tricky to test, but it should feel pretty rewarding when we actually are able to do this in-game. Oops. Let me see if I can be in the range here. There we go. And today we're going to be completing the bicycle kick and the volley kick abilities. They're going to look quite a little bit like the header ability, except for one thing. So currently, when we make a header, we need to be pressing the directional keys. So we actually have some form of velocity. And this actually gives us a directional vector as well, which we can use to figure out where the header is going to be going towards, right? So if you look at the code right now in the player head state, we currently use the player's velocity normalized to know where we're going to be shooting. However, for the volley kick and the bicycle kick, we want the player's velocity to be equal to 0. So there's no way for us to figure out where to aim. And sure, we could be using the heading of the player, but that would mean it's only going to be in two directions, either vector.2.right or vector2.left. The shots will always go straight, and it wouldn't be that interesting. So we do want to keep our control scheme pretty simple. So I do want to only keep two action buttons for both player 1 and player 2. You have to think, especially if you have two players on the same keyboard, the less keys you use, the better it will work out. So we need to come up with this alternative solution. And the one I've come up with in terms of simplicity is that we actually don't need to aim. We'll just auto aim for the player. We'll just pick a random spot within the goal. We'll probably have a few positions here, and then whenever we do a bicycle kick or a volley kick, we'll just aim towards that direction. And it'll be a little bit of a luck factor, but at least it will be fun to do. And it'll stay simple. So for that, let's go ahead and start by creating our targets that we can aim for. And we're going to build this in the most generic way possible. So let's hop over into the goal here. And let's create a node 2D, which will contain our various targets. Let's call these targets or goal targets. Targets is fine. And then here we'll have a couple of node 2D children that we're going to drag. So let's bring this one maybe here. I think would be fine. I guess if we aim towards here, and then let's duplicate it and then bring this one down. And let me show you the transform that I'm using. So I'm using 22 minus 56 for the first one. I guess we can call this top target. And then I'm using 22 minus 35 for the middle target. And I'm going to duplicate this, and I'm going to call this bottom target, and I'm going to drag it. Oops. Target. And I'm going to drag it down to about here. So this is 22 minus 10. Okay, and then we're going to need access to those children, but rather than pick them one at a time, we're just going to look at the parent and then just have the parent give us a random position. So let's go ahead and access that parent as unique name. Targets, let's hop over into the script, and we're going to need an honorary variable. Okay, and then here we'll just have a method that we can called get random target position. This will return a vector2, which will be the global position. It's going to be the same. Like right now, this is a local position, so we're going to be returning the global position for those objects, which will be equal to the local position in our world view here. So everything here is local. So back here, let's just return a random point. So we can look at targets.getChild. And here for the index, we're just going to pick a random one. So it will go between 0 and let's get the number of children. Get child count. And range, get child. Okay, and we actually want to return the global position for that object. There you go. Okay, so with that done, let's hop back over into the player. So one thing that we'll need to know in the player is which goal we're aiming for. Remember, we'll have a team on this side and a team on this side. When they start off, they need to pretty much be aware of where they're shooting and what they need to defend. And this is going to be important for the volleying and for the bicycle kick, but also it's going to be important down the line when we build our AI. Like, we need the characters to know what they should be defending, where they should be attacking, and so forth. So currently, our players have a hard dependency on the ball. We're going to create 2 additional hard dependencies for things that they need to be aware of. So we'll have the on goal and the target goal. So hop over into the player scene. Let's go into the script. And here, let's create 2 exported variables. Let's call the first one on goal, which would be of type goal. And then let's create a target goal as well. All right, and then back into the world view, let's make sure we set these up. So for now, these 3 people will be part of the same team. So I'm just going to set the on goal to be the goal that is on the left-hand side and the target goal to be the goal on the right-hand side. So the next thing we'll need to know is whether the player is facing towards the target goal or facing towards their own goal. And for this, we're going to be using a very handy method that you'll be using across all of your games, which is the dot product of 2 vectors. So here we have a common problem where we want to find whether 2 random vectors, A and B, are roughly looking towards the same direction. And when I say when they're roughly looking towards the same direction, I'm pretty much saying that they should not have an angle that's greater than 90 degrees between them. So if you take the vector B here as reference, for example, the vector A can go somewhere between here, right? I think right now it's about at 80 degrees. It can go between this vector here at minus 90 degrees all the way to the other side here at plus 90 degrees. And as long as the green vector is somewhere in this area, then we can say that A and B are looking towards the same direction. And we're going to be doing this on our end to figure out whether the player's heading is towards the position of the goal. But you'll be using this across the board on all of your games. So just to make sure that we're all aligned here on the values of those vectors and the angles, let me hop really quickly on the unit circle. So this is the unit circle, and hopefully you're familiar with it. Basically, as I move my mouse around, it increases the angle at the bottom here that you can see in purple. And then on the unit circle, there is 2 lines that get drawn. The value of the cosinus is provided by the value in blue here at the bottom, whereas the value of the sinus is provided by the value in green. And as I move my mouse around and the angle increases from 0 degrees all the way to 90 degrees, you can see that the cosinus is always positive. It goes from 1 here all the way down to 0 here. So the angle goes from 0 to 90 degrees and my cosinus is always positive. However, as soon as I start going on the other side of this axis in the second quadrant, you can see that the cosinus is negative. And it's going to stay negative all the way until I come back around here into the 4th quadrant. So here, 2nd quadrant and 3rd quadrant are both negative values for cosinus, and then here, cosinus is positive again. So if my vector of reference is this blue line here, then I can just look at the value of the angle. And as long as my angle is between minus 90 degrees and plus 90 degrees, then I know that my cosinus is going to be positive. Okay, so just keep that in mind. And I'm going to go back to the circle that we had before, and I'm going to rotate it so that it actually looks like the unit circle. And this blue axis is going to be exactly like the blue axis that we talked about. So here we have the blue axis, and now my vector A is located a little bit towards the bottom because I rotated it as well. And so here, once again, right, the same question is, we want to figure out whether A and B are facing the same direction. Well, there is an operation in vector math called the dot product. And when you do the dot product, it basically returns a value. It's just a simple scalar, which is equal to the magnitude of the first vector times the magnitude or the length of the second vector times the cosinus of the angle between those 2 vectors. So how is this useful to us? Well, in Godot and in game development, a lot of times you'll be using directional vectors or unit vectors, vectors that only have a length of 1. That's going to be the case for us, by the way. Like the player's heading is either vector 2 dot right or vector 2 dot left. It has a magnitude of 1. And then the direction towards the goal, we're also going to pick a vector of dimension 1. So when you have both of those vectors length of 1, you end up having the dot product, which is simply equal to the cosinus of the angle. And if you remember what we just talked about in the unit circle, that cosinus is always positive if the angle is between minus 90 degrees and 90 degrees. And so what does that mean? This is exactly what we're looking for. If you do the dot product between two angles, you can figure out whether they're facing the right direction by just looking at the sign of the dot product, which is going to be equivalent to the sign of the cosinus, which is, again, always positive when the angle is between minus 90 degrees and 90 degrees. So this is something that's just extremely convenient. You'll be using it across the board. If you're looking for to figure out whether vectors or units or whatever are looking towards the same direction or the opposite direction, you can just use the dot product between two vectors. All right, so let's go ahead and use our dot product to figure out whether we are facing towards our target goal or not. And just FYI, again, like the vector towards the target goal is between the player here and this target goal. So this is the arrow that you have to visualize. Basically, my directional vector is going to be somewhere around here. My heading is going to be towards the right. And so when we do the dot vector, we're going to return the cosinus value of this angle, which should be positive if that angle is lower than 90 degrees. So anyways, let's hop over into our script, and we need to figure out whether we're facing the target goal as part of our moving state. This is where we need to know if we're making a bicycle kick or whether we're making a volley kick. So let's create a method here and to figure out whether we are facing the target goal. So is facing target goal, and we'll just return a boolean for now. And so here we need to have we need to figure out the direction between the player and the target goal. Unfortunately, we're currently in the moving state. This does not yet have access to the target goal and the on goal, which we just added. So let's once again pass those dependencies to our state so that they have access to those things. Let me just return false for now. That way it won't complain. So let's hop into our player. We want to pass the on goal and the target goal to our setup here. So maybe let me start with the setup this time. Let's see if he complains a little bit less. So var on goal, just have type goal, and then here var target goal, type goal. Okay, let's pass those over in our signature. I'll start with the on goal, and then target goal. Okay, let's set the values. So on goal, oops, context, on goal, and then target goal equals context target goal. Okay, and then let's pass those two new arguments whenever we set up our state. There we go. All right, and so it stops complaining. Okay, so we now have access to our target goal. So back into the moving state, we can now make progress on our method here. So first, let's pick up the directional vector towards the goal. So var direction to target goal. This is the player's position dot direction to the target goal's position. And the direction 2, by the way, it returns a normalized vector. Again, this is super important when using the dot product. We just want to make sure we're using normalized vector. Okay, so this is returned a vector of size 1, and then we just want to do the dot product between the player's heading and this vector. Okay, once again, the player heading has a length of 1. This has a length of 1. So this here returns the cosinus of the angle between player heading and direction to target goal. And we want to make sure that this cosinus, that this angle is smaller than 90 degrees, which case the cosinus will be positive. Okay, so let's go ahead and use this method here. So if we are facing the target goal, let's go and transition into the volley state. Otherwise, we'll transition into the bicycle kick state. Okay, and I'm going to go ahead and implement the volley kick, and I'll have you implement the bicycle kick. You'll see that they're actually extremely similar, so if you want a little bit more of a challenge, pause the video now and see if you can actually implement the volley kick yourself. It's going to be very similar to what we did for the header. The only difference is the player is not going in the air, so we are currently going to be using the animation callback, volley kick, here, so that we can get out of this state. So pause the video now if you want to do that challenge, otherwise you can just follow along with me. So in the volley kick here, let's go ahead and figure out what we want to do when we transition into the state. So once again, we'll want to play the proper animation. This one is called volley kick. And then we'll want to start detecting whether our ball is making connection. Body entered. On ball entered. I'm going to go ahead and create this method right away. And this takes one argument, which is our ball. And we then need to figure out if we can connect in the air. If ball.can air connect, contact ball. In which case we will go towards this random target destination. So destination, and let's pick our target goal, dot get random target position. Okay, let's create our directional vector, which is the ball's position going towards that destination. This is again a normalized vector. So let's go ahead and shoot the ball using our directional vector, and then we'll multiply this by the player's power. And let's create an additional bonus. I'll make this a little bit more than our header. I'll make this to 1.5 bonus power. Okay, and then we'll want to override our on animation complete. On animation complete. And here we'll just transition into the recovery state. Okay, so, all right, so just going back here, once again, for over the code. So when the ball is in the air, when we can interact with it, which means right now that it's in the freeform state, and we're pressing the shooting key, if we're not moving and we're facing towards the target, we're going to transition into this volley kick. And as part of the volley kick, we'll play the right animation, and then we'll listen to the connection between the ball and the player. When we have contact, then we'll picking a random position in the target goal, right here, right? One of those 3 points that we've defined earlier. And then we are going to shoot towards that point. Okay, let's try this out. All right, so picking up the ball, I'm gonna go in position, pass my teammate behind, get ready for a volley kick, get a pass and shoot. Let's try it again. Get a pass and shoot. All right, well, that was pretty underwhelming. Clearly there's a bug here. Let's use that opportunity to debug and see what's going on. So let's see. So at least we know we're entering in this state because we are playing this animation. So let's make sure that we actually make contact with the ball here. Back in the game, let me pass once again, get in position, get a pass and shoot. All right, so we do get into this method. So let's debug this one by one. Contact ball that can air connect. So I'm going to press F11 on my keyboard, which is equivalent to going into the method. It's going to go inside this can air connect method. Okay, and let's inspect here. The height is currently 6.4. Okay, so that's the problem. We have a height of 6.4 and we have a min of 10 and a max of 30. So the values that we set for doing a header are probably not going to work across the board for doing a volley kick and a bicycle kick. We can't have the same values, basically. It doesn't make sense to have just a single set of values. And I don't know if I want to create 2 other sets of values, especially as part of ball. I don't think it makes sense. So unfortunately here, well, I made a mistake. So we're going to change things a tiny bit. I'm not going to have those values given as part of the ball. I'm going to pass them from the state. So let me clear out those 2 exported variables. And then here, I'm going to pass these as arguments. And then the state will need to say what are the min and max values. Okay, so let's start by fixing the header state because the values we know are 10 and 30. So here, this is going to complain. Of course, let's create two consts, ball height min, 10 and 30. Oops. And let's pass those in. So you might be asking, like, why don't we create the can error connect here and check whether the ball's height is, contained within this interval? I mean, that's definitely a possibility, but we also would have to create that method as part of the bicycle kick and the volley kick. So you end up duplicating that method 3 times. So I don't know if it's any better, but again, those types of arguments are always a little bit tricky. So, okay, so I'm going to do the same now in the volley kick. And here I need to, so let me remove this breakpoint here. And let me create 2 new consts. Okay, what makes sense? I do want it to be somewhere in the air. I do want this to be kind of a special ability, so I don't want that to come for free. And then let's set a max height. So maybe this needs to be a little bit lower than the header. Let's set it to 20. Let's double check. So let's hop into our world view here and click on the ball, right click, editable children. Let's bring the sprite up by 20 pixels and see if that makes sense. Can we do a volley kick here? I think it should be okay. Feel free to change it if you feel like that's too high. But yeah, I think, at this point, we want to make it pretty easy for the player to have fun and make those abilities successful. So we have defined our 2 constants. Let's go ahead and use them in our canErrConnect method. Okay, and let's try this out again. Go in position, pass to my teammate, look towards the goal, get a pass, and shoot. All right, that's much better. Okay, cool. So I'll have you do the bicycle kick, but as I was thinking about it, I actually think the bicycle kick is going to be extremely similar to this. Now, you could say, well, why don't we create a common method and just have one derived from the other? That's definitely a possibility. I think it could work. Most of the code is, again, going to be very similar. All of those lines are going to be the same. We're just going to play a different animation, and then I'm going to have different set of constants. Another way you could do it is have just a default animation or default state with a different state properties when you enter that state, and then use that. That's also a possibility. I don't know if it will make the code cleaner. Maybe here, for the sake of simplicity, I'm just going to copy paste what I have here. And this is probably the only time I will do this in this series. So forgive me, those abilities are very close and the code is just so small. Sometimes it just makes for more clarity. So hopping over into the bicycle kick, I'm going to change the values here. I'm going to set the min height to 5, and then set the max height to 25. Bonus power, I'm going to set that to 2.0. It's going to be like a really powerful ability. And then bicycle kick. All right, let's try this out. And let's see. I'm going to bring both players towards the right, so it'll be easier to test the various abilities multiple times. All right, so here I'm going to pass to my teammate and get a pass and do a bicycle kick. Bicycle kick. Aha. Oh, yeah, this is my bad. You might have caught this. You might have actually seen the error before me. But this here returns 3. So range returns a value between 0 and 3 inclusive. From 2, it's inclusive here. So we can actually get the value 3. And there's no children with that index because it's 0 index, right? There's only 3 children. So we need to have a -1 here. Okay, let's try this again. I want to make sure everything is pretty stable here. Go towards the goal. All right, let's try a couple of things. So let's try the bicycle kick. Pass, bicycle kick. Good. Let's try the volley kick. Facing here, volley kick. Okay, this works well. Let's try the header. Header is a little bit trickier to do with just one keyboard, 2 players. Let's see, I'm going to start going this way and header. Okay, great. Well, this seems to work pretty well. So let's go ahead and persist our changes. Added header, not header, volley and bicycle kicks. All right, perfect. All right, so we have a couple of minutes left for this episode, and I did want to fix something that kind of looks odd in my opinion. Let's say I pick up the ball here, and I'm going to ask for a high pass from my teammate. And as I get the high pass, I'm going to start walking towards the ball. So getting a pass and walking towards the ball. You can see how the ball kind of went over the head and then just kind of dropped down. And I think it's okay to make this sort of control, but the fact that the player can still move fully and have all of the abilities kind of makes it a little bit weird. So I created an additional state for this that I wanted to add, which is the ability to control the ball on the player's chest. So we are going to create this new state, which comes with its own animation and frame and so forth. So this is going to be a little bit of a repeat exercise. But again, it's good exercise to just repeat those things so it becomes extremely familiar to you. So let's hop over into our player. We're going to create a new animation. Let's call this chest control. Let me hop into the 2D view here so we can see that player. It's going to be a single frame. I'm going to make this 0.1. It's not going to loop. And then hop over on the player sprite and pick frame 42. And then create a keyframe here. You can see the player kind of boasting here. We'll have the ball kind of fall on the chest and then come down. Okay, so whenever we create a new state, we'll need to add it to our player's enum. Let's start with that. Where is our enum? Right here. We'll need to add, let's create an empty skeleton class like we've been doing for the other states. Let me make sure it's located in the right position. Player, state, chest control, and give it a class name. Player, state, chest control. This inherits from player state. Let's add it to our factory, player factory. All right, so what do we want to do in that state? Well, it's going to be very simple. And actually, let me describe what we want, and I'd love for you to try to do this on your own. So here, the only thing we're going to be doing is playing this animation and then waiting half a second. That's all we're going to do. The gravity is going to take care of the ball by itself. It's going to drop down. And then after half a second, we should transition into the moving state. So, try to figure out how to do this. It should be pretty straightforward. Pause the video now. If you can, just try to do this. So again, we want to wait half a second before we transition into the moving state. All right, so hopefully you had a chance to try this out. So we're going to need a constant to keep track of that time. I'm going to call this duration control, chest control, I don't know, control. Let's set this to half a second, 500 milliseconds. We're going to need to keep track of time, which we'll set to the current timestamp. When we enter the state, we'll play the right animation, which is called chest control. And we'll need to keep track of time. So let's mark that timestamp. Once again, I've repeated this so many times that I don't know if this is actually important. You might have omitted it, and that's perfectly fine. And then in our process method, we're not going to be using delta. We just need to check on the time. So if we've spent enough time in this state, time since control, we'll just want to transition into the moving state. Oh, and one thing maybe we want to do is stop the player from moving. Otherwise, it's just going to be gliding in that boosting state. So let's maybe set the velocity here to 0. All right, so how do we transition into this state? Well, we need to do something when the ball comes in contact with the player. So this currently happens in the ball state freeform. This is the only state where the ball can be picked up. It's happening here on the on-player enter. So here, once again, rather than check on the player's on the player's attributes, I'm going to call a method on the player. So let's just say body dot control ball. Okay, I'm going to create this on the player side. All right, and so here, what do we want to do? Well, we don't want to enter that chess control state all the time. We basically want to only enter it after if the ball's height is greater than something. So we could have an exported variable here, or we could just have a constant. Maybe I'm just going to have a constant. Another reason why I'm favoring constants against exported variables is, I guess in Godot, so many times I've had to those values were reset for one reason or another. And then I would play test the game, something would not work, and I would go ahead and check, and for some reason the exported variable had been reset. It's sometimes a little bit tricky. So the constant, at least you know what the values are, and they will never change. Anyways, enough of that. So I'm going to set this to, let's try 10. Shouldn't happen all the time. So if the ball's height is greater than 10, then I will transition into my state. Switch states. Okay, and I guess we could pass in the ball here as an argument as well, but I think this is fine. All right, let's try this out. Okay, picking up the ball, I'm going to make a pass here and get a pass, and there we go. Okay, and this works well. Maybe 500 milliseconds is a little bit too much, but I think this is fine. It will make also the player a little bit more vulnerable when they're in this state. They'll be able to get tackled. So I think it'll create some interesting gameplay mechanics. So let's go ahead and persist that change. And with this third state now implemented, this is going to be it for this episode. I don't think there's anything too complicated today, so I did want to provide a little bit more coding challenge. And hopefully you took the opportunity to try things out on your end, and hopefully everything is really starting to click for you. If there's one key takeaway from this episode, it would be how to properly use the dot product between two vectors. This is just so critical, and it's going to be useful for every single game that you're going to be building moving forward. Anyways, thanks again for watching this series. The soccer field right now is getting a little bit lonely with just those three little guys. So next episode will probably be a good time to actually spawn entire teams using data that can be stored in JSON files. And yeah, I really hope that you're learning new things, enjoying this series, and please don't hesitate to let me know if you are stuck, if you have any questions or comments, or anything that's not working on your end in your code, or if you just want to talk about your day, just go ahead and use the comment section below. If you do like this video, if you do like this series and this content, please do consider clicking the like and subscribe buttons. Get those YouTube algorithms to work in my favor. I'm almost at 1,000 YouTube subscribers, which is just crazy to me. And once I do reach that milestone, I will have you pick the nature of the next tutorial series. Time to take a quick break, and I'll see you in the next episode. Cheers.